Hi, and right now we are going to question 7, and we're going back to sets and Venn diagrams a little bit. It's given by that the universal set is given by some inequality. And notice now x is a real number, so yeah, it doesn't have to be an integer. It can be 5.333331 or something, and that would belong inside this range, right? And then we can see, okay, A we have that, B we have that, C we have that. Oh, but C is special because x must be prime. So if it has to be prime, then that helps. And I mean, it has to be singular numbers and not just a whole range. But these are giving whole ranges, right? Real number can be. It's a whole range. So 7a, represent each of these sets on a real number line and express each of the sets in a set builder notation. Okay, and so let's get a real number line. And we can see universal set goes from 0 to 15. So let's just do that. Oops. So of course, I'm sketching here, but on paper, it would be good if you actually really drew it out nicely and make sure that the interval between each number is the same. Okay, and I'm gonna need a bit more space here. Okay. So universal set. Okay. Let me just move all this down to give space. So the universal set is 0 to 15, and not including 0 and not including 15 because it's strictly greater than, strictly less than. So we don't include the ends. So 0 all the way to 15. And then we say, okay, set A is between 3 and 9, and so not including 3, strictly greater than 3, and all the way to 9. And then B is include 2, but we don't include 8. And C is kind of a special one because where x is a prime number, so it's really like singular numbers. So what are the prime numbers in this range? So I'm just going to write down the prime numbers that I know, like in general. 7, 11, 13. And it has to be strictly less than 12, so 13 is out. 11 is strictly less than 12, and it's greater than 4. 7 is fine, 5 is fine. 3 is already less. 3 will be less than 4, but you need to be greater or equal to 4. So it's only these three numbers, 5, 7, and 11. So really, actually, you can write like this, 5, 7, and 11. But since they want it on a number line, so 5, so it's not a range. You just include this point 5 here, include this point 7 here, and include this point 11 here. Yeah, that's how we do it. And now we want to represent each of the sets in a set builder notation. And what it really means is just you're trying to, set builder notation means it's like x, where x is, you try to describe it. And so A union B is everything inside here, including everything inside here. So B starts earlier, right? So we include everything here. So even though A doesn't include 3, B has 3, so we include 3 as well. Include everything here. And B ends here, it doesn't have 8, but 8 belongs in A, and A goes all the way to 9. So A union B is basically include 2, go all the way to 9. So how we write it is simply x, where x, we include 2, we go all the way to 9. Yep. For double I, A prime union B prime, so whatever is not in A with whatever is not in B. Okay, so this is a bit more tricky. And to do that properly, really, I think I'm gonna have to actually write out what is A prime. So let's do it here. A prime is simply here. So A doesn't include 3. So I'm gonna include it now. Everything here. And of course, I think the universal set doesn't include it, so we can't include it as well. We can't include 0. So A prime. And of course, A includes 9. Look at the red one. A includes 9, so we can't include that. and everything else, we go all the way. That's A prime. And then I'm going to pull up another color. Let's use pink. And B prime, okay, so I'm really stretching for space here. I'm just going to write it here, where B prime is simply this, right? Because look at the blue one now. So blue, B includes 2, so I don't include it. But everything else goes. And B prime, so B, look at the blue one again, B doesn't include 8, so I do include it, 8 onwards. Then of course, I don't include this because my universal set doesn't include it either, so I can't have it. So that's B prime. So now that I got A prime and B prime out, I'm looking at them union, so I just include everything, and you can see that everything here is also here, so A prime is bigger, so basically I just take it from here, A prime. And B prime has this little bit extra that A prime doesn't have, so I just take it out from here, and the rest is all included. So what I want is x is going to be strictly greater than 0, and it goes all the way to 3, and it includes 3. So we're going to say x, where x is strictly greater than 0, and it goes all the way to 3, and it includes 3. And we also include this part, so greater than or equal to 8, where x greater than or equal to 8, and we go all the way to the end, strictly less than 15. And you put a comma in between to say that you want both ranges. And that's it. Now 7b. Find the number of elements inside B intersects C. So let's look at B intersects C. That helps us. B is blue. I'm just going to color code it. C is orange. So, all right. So number of elements B intersects C. That means the overlap. That means what is in B must be in C, or whatever in C is in B. So we can see clearly here that 5 belongs in C. It belongs in B as well. So 5 is inside. 7 is inside. 11 is not in B, so that's not included. So it's only 5 and 7, and that's it. So number of elements is simply, if I were to write it this way, the B intersects C only has 5 and 7, and the number of elements inside is 2, because 2 elements, 5 and 7. Now I think it's worthwhile to note that if I ask you that the number of elements, for let's say if it's not C, let's say like A and B or something like that, I can't give you the answer because there are infinitely many numbers in between here. Right? This is going a bit deeper. How many numbers are there between, let's say, between 4 and 5? Infinite. There are infinite numbers between 4 and 5 because 4.1 is a number, 4.1111 is a number, right? And this is just bonus, okay? And you don't have to, if you don't, or if you're done with this question, you can move on. But I just want to say, like, how many numbers are between 4 and 5? You have 4.1, you have 4.01, and you have 4.0001, and they're all numbers. And so they're actually infinity numbers between 4 and 5. So if I ask you, like, how many elements are there, in A, it does not make sense. There are infinitely number of elements. You can have so many numbers. So it will not make sense. The only reason why this question makes sense is because C has specific numbers inside, 5, 7, 11, and that's it. Then you can actually count. When it's a range, like between 3 and 9 or something, it's infinite, 6.55555, 6.9999. You have so many numbers because you have infinitely many decimal places. Yep. And so that's it. And so of course the question doesn't ask that because it doesn't make sense.